Hi everybody, this is Mrs. Lehman from Math with Mrs. Lehman. I'd like to say Happy Pi Day, everybody. Now they're all hungry, it's before lunch. And I am here today with my 6th period class. Oh yeah, alright. So today we're going to do a little throwback to Mod 4 in our bell ringer, and we are writing expressions. Now I didn't write algebraic expressions, but that's what I meant, okay? You have to write an algebraic expression. So it's a math problem with symbols and letters and numbers, okay? But it's not, I had some kids earlier today just writing these out in sentences. They're like, Jim ate 4 more Skittles than Marie? Wow! They wrote the expression, wow. That's a different kind of expression, okay? So anyway, I'm just kidding. An algebraic expression is what we're looking for. So if Jim ate 4 more Skittles than Marie, write an expression for how many Skittles Jim ate. Who can help me out on that one? Cam, thank you.
4 greater than 10?
Okay, so Cam just said m is greater than 4. This is not looking for an inequality. All right, so when it's looking for an expression, it wants you to add, subtract, multiply, divide. Okay, so what would that be if you have that?
M plus 4?
Very good. So I saw a few people had an inequality. If they want an inequality, they will give you that word to use. All right, so m plus 4. So Marie's amount plus 4 more. And the key word that told you that is simply 4 more. And then than tells you that you're going to have Marie's amount, and then next you add. All right, the next question says, Sierra shared her M&Ms equally among her 5 siblings. Now, in examples 1, 2, and 3, they did not tell you what variable to use. So you have creative license there. You can pick whatever variable you want. In number 4, they tell you you have to use G. So, again, it's up to you. Depends on the problem. So Sierra shared her M&Ms equally among her 5 siblings. You want to help me out on that one, Michael?
S over 5?
S over 5, okay. Now, I had a girl earlier today say she did not want to use S because the S and the 5 look a lot alike. So maybe we want to use N. It doesn't really technically matter. So N divided by 5, all right. This would be the more elementary way of writing it. Is like this, but you definitely want to write it as a fraction. That's typically how you will see that. You'll never see it like this, all right? That is not how you would write that. All right, number 3, Veronica increased her average by 9 points this quarter. Go, Veronica. Who can tell me what that would be? If you increase something by 9, you are doing what to it, Jonathan?
Adding 9.
Very good. So let's use V for Veronica. Plus 9. Dominic's team won twice as many games G this year, then increased the number by 1. What would we have for that one? Malaya.
G plus 1.
Say it into the mic, please.
2G plus 1.
Very good. 2G plus 1. I like that you put that 2 out in front of the G. You used a coefficient, we call it. Right here, that's a coefficient, and that indicates what operation? Everybody? Oh, good job. All right, we are moving on to our math joke of the day. Here we go. You know what's odd? Every other number. Some of the kids actually get this one. So, 1 is odd, 2 is even. So we've got odd, even, odd, even, odd. So what's odd? You know what's odd? Every other number. Get it? I had to explain it to a few classes, so I feel like now I have a captive. I don't have a captive audience on YouTube because you can just click stop and go to the next video. It's the beauty of YouTube. But anyway, if you need the explanation, there it was. Moving on. All right, so we have some questions from yesterday's lesson. And today we are focusing on finding the area of triangles. Yesterday you don't have to throw your stuff. Just kidding. Some papers fell. Yesterday we focused on finding the area of right triangles only. Well, wouldn't that be a perfect world if we only had right triangles? No, it wouldn't be perfect. All right. Now today what we're going to do is find the area of any triangle, okay? As long as we know the height and can figure out the base, we are golden. So I need you to turn to page 8 though before we get started, because The modules take us down a meandering road to get to this realization that you can split up a rectangle different ways. So number 4 here on page 8 in module 4 says, lesson 2, I believe, Mr. Jones told his students they each need a half of a piece of paper. I'm guessing this is a 6th grader because Calvin cut his piece of paper horizontally, classic hamburger bun style, right? Cut it right down across the middle. All right, and then we've got the Yahoo Matthew. And Matthew cut his piece of paper diagonally. Now, they try to trick you and they say, which student has the larger area? Explain. Now, I want you to answer a different question for me. Did they both follow Mr. Jones' directions? Yes. If you say yes, everyone say yes.
Yes.
If you say no, anyone say no? All right, good. Why? Who can tell me why? Go ahead, Tori.
Because he didn't say how to cut it in half, he just said to cut it in half.
So you're saying that both of those papers do represent half. Yes, you are correct. All right, now I'm going to demonstrate this to you in case you think I'm full of baloney, which, whatever. I'm going to roughly, this may be a little tiny bit off, but I'm going to do my best here. So let's say we take this section that I'm outlining in blue. I'm going to do a different section here in green. Watch this. It's magical, kids. Ta-da! Yeah. All right, let's see. And then you flip this around. Whoa. Whoa, you can't do that with an overhead. Just kidding, you feel really good. Do you see how that's the same area? They match. I'm pretty proud of myself. Look how well I did. Go, Mrs. Lehman. Just kidding. I have to give myself my own pats on the back, I guess. I'm just kidding again. I'll just shut up and show you. There you go. Any questions? All right, so hopefully that makes sense to you. In the next example, it says Ben requested that the rectangular stage be split into 2 equal sections for the upcoming school play. The only instruction he gave was that he needed the area of each section to be half of the original size. So this guy's up there going, hey guys, I need you to split this stage into 2 sections. They both have to be equal, all right? It says, if Ben wants the stage to be split into 2 right triangles, did he provide that crew enough information to do that? No, why not? What are some of the ways that he could have cut this stage up? Or these people that are helping on the pit crew? Stage team, whatever they call it. How could you cut that up? Caleb, what's one way?
You could cut it in half, like, vertically.
Very good. So you want to draw a vertical line? Is that what you mean? Or you mean a horizontal line? Vertically, like this? All right, yeah, that would work. What's another way we could do this? Cam?
Horizontally.
Yep. We got the ham, or the hot dog and the hamburger ways. And then, what do you think, Jonathan? The diagonal way, we say, yep. Yeah, could go that way. Or, you could, this is mind-blowing, kids. Could have gone this way as well. What? All right, now, you guys at home can't see the awesome reaction that Aiden had to that. I wish you could see, but you can imagine. All right, now a classic problem that you'll encounter when dealing with area is you will be given the area and then you're going to be given one of the other measurements, but you'll be missing one of the measurements and you have to set up an equation to figure out what that missing piece is. So let's read this next one. It says if the area of a right triangle is 6 2/22 square inches and its base is 3 11 inches, write an equation, that means it has to have an equal sign, that relates the area to the height and the base. Sounds a lot to me like our formula we learned, right? And then we have to solve it to determine the height. So, area of a triangle would be what? I told us it's a triangle, so Jacob.
base times 2 divided by height. I mean, base times height divided by 2.
There you go. Base times height divided by 2. So b times h divided by 2. All right, now we're going to plug in what we know. Who can tell me what to plug in? Somebody I haven't heard from yet. Straight up there in the reading. Just read. Blaze, go ahead.
3.11 inches is the base.
Very good. So we can replace the base. So we're going to have the area equals something, and then we're going to have the base, which is 3.11. Do we have the height? No. So that remains an unknown. That's why we're using a variable. And then 2. All right, what else can I fill in here? Cassie, thank you.
The area.
Very good, which is?
6.22.
Very good, 6 to 2200. So this is what we have. Now this is really your first two-step equation that you've had to do. You guys did a really excellent job with solving one-step equations by using the inverse operation to both sides to isolate the variable, get that variable all by itself. We're going to do the same thing, but now instead of just doing one operation to get rid of all the numbers with the variable, we're going to have to do 2. Okay, that's why they call it a two-step equation. We've got 2 things going on over here with the variable. We've got multiplication and we have division. So when you have a case like this, let's get rid of the division first, okay? So I started to say okay, and I was like, okay, all right. Anyway, so if we have divided by 2, we want to do the inverse of that. What's the inverse of dividing by 2, everybody?
Multiply.
Yep, multiply by 2. So we're going to multiply each side by 2. You do it to one side, you got to do it to the other. Now, what will that do to this right side here? What will that cancel out? Nope, it doesn't cancel out the h. The h stays put.
2 to the bottom.
It takes away the 2, right? It gets rid of it. So 2 divided by 2 is 1. So if we have this quantity, 3.11 times h times 1, we don't have to write that 1. It's just 3.11h now. All right, now over here, if we double 6.22, what would that be? Very good, 12.44. All right, now we have one more step, 2 more steps. But what do we do to get the h by itself? Right now, that h is being multiplied by 3.11. What would we want to do? Cassie?
Divide.
Very good. So we're going to divide each side by what? Some people are saying 2 and some people are saying 3.11. 3.11 is the correct answer. If we divide it by 2, you're doing exactly what we just undid. Right? You'd be redoing it again. You'd go back and forth all day and never accomplish anything. All right? So we want to get the h by itself. Now, since we divided a number by itself, that's going to give you 1h. And you guys know we do not use a coefficient of 1, so you're just going to write h. If we have 12 and 44 hundredths divided by 3 and 11 hundredths, what would that be? Michael?
4.
4. Very good. So 4, do we want inches or inches squared if it's a measurement of the height? Inches. Very good. So, excuse me. 4 inches is the height. Any questions there? All right, we're going to move on. Yes, that was a question? Okay. If you have a question, please don't hesitate to interrupt me. I can always pause the video if need be. All right. So, you guys had some homework on your problem set yesterday. So, I'm going to have you guys look at your own homework right now. And I just want to emphasize the value of showing your work, okay? Your work is like a roadmap to somebody grading this to see what path or what route you took to get to the answer, okay? And even if you took a wrong turn somewhere, it's still worth something, all right? So you don't want to erase things. You don't want to try to clean up your paper by, like, you can work neatly without erasing your side calculations and that type of thing. Because I've had some kids that think like, oh, I've got to multiply this number off to the side, then they'll erase it afterwards. You want to keep all that stuff on your paper, because as a teacher, I can look at that and say, oh, okay, that's where they made their mistake. It was a calculation error, right? And I can really understand what steps you took and where you may have misstepped with that. And that's also how you get credit on things like assessments. So anyway, what I'm going to do is have you kind of grade your own, okay? I'm going to assign 4 points for each of these questions, all right? The first step to solving any of these is you're finding the area, okay? So you need to know the formula. So what is the formula for the area of a triangle? Hold it 1 second, viewers. Oh, I said I'll be right back, but I don't remember what I was talking. So area equals base times height divided by 2. Remember, it's like a rectangle split in half, right? Divided by 2. So what we're going to do first is identify. All right, so what I want you to do on your paper actually is put +1 if you had the formula listed, right? +1. Maybe we should put a little circle around it so you know that's not part of the math problem. All right, so that's worth 1 point right there. All right, you know what you're talking about. You've got the right formula for a triangle. Now, the next step would be to plug in the correct numbers. So which 2 numbers do I want to use here? Jonathan.
9.1 and 31.2.
Very good. Yes. So what you're looking for is the right angle, and then you're looking for the 2 sides adjacent to that angle, the 2 sides that form that vertex. Okay? You're looking for a perfectly square corner there. So we have 31.2. Now, if you put 9.1 first, that's fine because we know the commutative property of multiplication says it doesn't matter which way we add or multiply. So, actually, if it's a commutative property of multiplication, just multiplication in that case, but you know what I'm saying. So 31.2 times 9.1. Now, here's the thing. A lot of kids say, I don't think I can use a calculator in my math class. Yeah, you need to learn how to use a calculator, but you also need to learn how to show your work while using a calculator. And my rule of thumb is if you are going to type it in your calculator, it better be written on your paper. So I have everything I need written down. So 31.2 times 9.1. I'm going to do that step first, and that's 283 and 92 hundredths. I still have to divide it by 2. Right, so this would be worth a point right here. So another point. Let's say this is worth a point, right? So doing some of the actual calculation work. And then divide that by 2. And you would get 141.96. And then that would be worth a point. But then you also need to label, right? So a lot of kids forget to label centimeters squared. So that would be worth another point. So I want you to look at your paper right now and go, how many points did I get? Did I write the formula? Did I plug in? Did I do then the calculation part of it? And did I write my answer and label it? So we're talking about 1, 2, 3, 4, 5 points, right? So by a quick show of hands, you can be honest, right? The YouTube viewers aren't going to know who got all of them correct and who didn't. Who got all 5 correct? Very good. Who got 4 out of the 5? All right, not bad. Who got 3 out of the 5? Let me guess. You didn't write your formulas.
Yeah.
Calculation error?
Yeah.
All right, so here's the beauty of that. If you just made one calculation error, right, you still are getting some points versus getting no points for getting it wrong, right? So your work is very valuable. All right, let's look at this next one that kids struggled with. This one should not say 5 centimeters right there. I don't know what happened. I'm not sure. Now there's dividing by 2, which is the same as multiplying by 1/2. So we're going to use multiplying by 1/2 in this case because we have fractions. So we have 1/2 times the base. We're going to use 5. Now, how do I write 5 as a, well, we'll say that for the next step. Let's pretend I didn't draw that line under there. Times 3 and 3/4. So we had to pick the correct 2 sides. Again, these ones that are adjacent to this little box right here that indicates a 90-degree angle. So area equals 1/2 times 5 over what? How would I make that into a fraction instead of a whole number? Cassie is saying 1. Put it over 1 times 3 times 4 is 12 plus 4 is 15 fourths. Very good. So that's what this looks like now. So this would be worth a point. This right here, this would be worth a point. Putting in the correct form would be worth a point. However, if you did this on a calculator, I think you could get away with not doing this part of it, because on our scientific calculators, you can type all of that in without doing the improper fraction conversion, as long as you know how to use that ABC fraction button. So anyway, if you multiply straight across here, you have 1 times 5, which is 5. 5 times 15 is going to give you 75. And then 2 times 1 is 2, times 4 is 8. So you're going to get 75 over 8. Now, to convert that into a mixed number, you're going to take 75 divided by 8. Well, we know 8 times 9 gives us 72. You subtract, you get 3. So you're going to take your leftover amount and put that as your numerator and keep that denominator. So you're going to have 9 and 3/8, and your answer will be kilometers squared. All right, so again, let's look at this. You have 1, 2, 3, and then we'll say this one, the answer is worth 1, and your label's worth 1. So that one's out of 5 as well. All right, who here would have gotten all 5 points? All right, nice work to you. Who would have gotten 4 points? Okay, do you guys see what you missed? Who would have gotten 3 points? Okay, anyone less than 3? Okay, so calculation, did you pick the wrong sides? All right, so you picked the wrong sides. You got the wrong answer. Okay, so again, you're looking for the sides that form the right angle. Okay, all right, we've got a few more to go over, and then we need to get scurrying on to the next lesson. So, all right, check your work, please. I'm going to demonstrate this to our viewers. Area equals base times height divided by 2. Now, in this case, this and this line, which I shouldn't have used black there, this line and this line are the perpendicular line. So we want to use 2.4 and multiply that by 3.2, and we're going to divide that by 2. All right, so again, we're up to 2 points here. 2.4 times 3.2 is 7.68 divided by 2. Divide that by 2, and you get 3.84 inches squared. Who here did a nice job with that problem? All right, good work. I think a lot of things happen when we start dealing with fractions. You know, kids kind of lose their confidence a little bit, and they're not as skilled sometimes. So a recommendation would be to continue working on multiplying and dividing fractions, converting improper fractions to mixed numbers, and vice versa. All right, which 2 numbers do we want to use in this one? Again, formula is written every time. Malaya, what would you use? Very good, 60 and 11. And when you multiply that, you get 660 divided by 2, which is going to be 330 millimeters squared. All right, any questions on that? Does everyone understand what they did wrong and what they would need to get full credit? All right, so you got to be, again, really careful about making sure you're showing each step, because a teacher should be able to look at your paper and go, this is what they did first, this is what they did second, that's what they did third. So what I had is some kids like this, I'm going to circle it in green, they'd have this on their paper, and then they were going, oh, let me erase that and clean this page up. No, don't do it, kids. Don't do it. Don't erase your work, all right? All right, today what we're going to do is work on lesson 3. And there's a little trick to this. So when you guys learn to find the area of a rectangle, you know, it's just length times width, because the sides were 90-degree angles. And then all of a sudden, you know, you come to 6th grade and it's like, oh, you have to find the area of a parallelogram, and that's base times height. And I gave the whole demonstration of you want to make sure you're at a 90-degree angle with the floor, right? So the same thing is true of a triangle. So sometimes we do not have 90-degree angles in our triangle. What if we had something like this, a very obtuse triangle? Okay? Does anyone think that they know where the height would be? Because there is no 90-degree angle. Jonathan, do you want to come up and try?
Yes.
All right. Quick, the viewers are waiting for you. This kid's good. Nice work, Jonathan. Beautiful. All right, so the height does not have to be part of that triangle, okay? It does not have to be part of it. it could be obviously not a side. So right here, that's going to form a 90-degree angle. You are always looking for the perpendicular lines. So you wouldn't be able to find it with like this side. I'm going to do this in red and then erase it. Like there's no, like that doesn't form a 90-degree angle. You wouldn't do it there. All right, so you're looking for that angle that's going to look like that. Now, what really goofs kids up is, I'm going to erase kind of what John did here in the middle for a reason. I'm going to retrace this. All right. And watch this. Oops. I'm going to move this over here. Now look at, kids get thrown off like, oh no, the triangle's upside down. Guess where the height still is? Right. It's right there, right? So what if I rotate it like this? Oh no! That distorted the image a little bit, but same place, okay? Now, the base, what New York State wants us to do, and it kind of is a waste of time if you want my opinion, all right? They will have the triangle set up like this maybe, and they will say, okay, here's the right angle. They want you to split this into two different triangles. So then you have to find the area of two different triangles and add those together. What if I told you, kids, there was an easier way? Yes, there is. Now, the height is the same for both of these triangles, right? What you have to do is account for this entire base instead of just looking at this side or that side, okay? That doesn't look like a smiley face when I do that. All right, so let's say this is 2, this is 3, and maybe this is 4. That does not look, not drawn to scale, obviously. That looks terrible because that side's way shorter than the other one. But anyway, what would we use for a base then? What number would I use for a base? Raise your hand if you think you know. You can figure that out. Michael?
4.
Nope, that would be our height. That's our height. What would we use for the base? Think about it. We want to find the area of the entire triangle. Cam?
5.
5. You are correct. It is 5 because you have to add this 2 and this 3. And again, that is terribly out of scale. I kind of want to erase that because that's so bad. All right, so let's look down here at these examples. Now, we're going to do it the Mrs. Lehman way, not the Mrs. New York State way. All right, so we are going to scribble this out. And we're going to use those 2 rows to essentially show all of our work. Looks like somebody was busy doing their homework ahead of time, Malaya. All right, so just check it over, Malaya. Make sure now that you've actually been in class. I have students that are so dedicated, they do their homework ahead of time. That is incredible. All right, so I need the base and the height. Let's write our formula. Area equals base times height divided by 2. All right, area equals what will we want to use as our height here? Let's do the height first. Malaya, 12. Very good. So we're going to use 12. So let's plug in 12 times. Now, what do we want to use as the base? Michael.
21.6 centimeters.
Very good. 21.6. If you add the 9 and the 12.6 together, you're going to get 21.6. And that's what we want to use up here. So I'm going to use parentheses actually to multiply. 21.6. And we're going to divide that by 2. So we're going to use our handy dandy calculator, which is right here. All right, 12 times 21.6 equals 259.2. Let's write it down. 259.2 divided by 2. Bring my calculator back. Baby, come back. Any kind of fool can see I was wrong and I'm losing more subscribers. All right, so we have 129.6 as our final answer, 129.6. And what unit would we want here? Centimeters squared. You guys are good. All right. You guys see the think you can figure that out? Right? Again, account for the entire base. So let's look at this next example before it's time to go here in a few minutes. What do we want to use as the height? Somebody I haven't heard from. Nice and loud. Somebody who's good at shouting at me. None of you are good at shouting. Oh, Malaya's stepping up to the plate. 5.2 feet. Now, what would we want to use for our base? Again, you're looking for the perpendicular lines. What do you think, Michael?
11.9 feet.
Very good. This child's very good at adding these two numbers together. 11.9 feet, which he giggled, but honestly, there are going to be kids that come in with this, and they're going to be like, I only found half of this triangle. All right, so you're going to write the formula every time. All right, let's look at this next one. The fraction one really gets some kids. So what is the height in this one? Perpendicular lines. You can use 2 and 5, 6. Now, this is the entire base. 2, and then you add 5, 6 to it. 5, 6 to it. You will get what? 2. It'd be 2 and 5, 6. Right? So, these look like little sailboats. Come sail away, come sail away, come sail away with me. All right, so we are going to, I don't know why I'm singing. It's really not my forte, kids. All right, we're going to use which formula since we have a fraction? Emma, yell it to me. Very good. 1/2 BH. So, you're going to plug in 1/2 times the base, which is 2 and 5, 6, times the height, which is also 2 and 5, 6. Your next step is to turn these into what? Begins with I and ends with improper. Improper fractions. Very good. I don't know how you guessed that. Now, 1/2 times 2 and 5, 6. What would that be? 2 times 6 is 12. 12 plus 5 is 17 over 6. You multiply the denominator times the whole number and then add the numerator. Times 17, 6. You guys have some calculations to do, but your job is to finish this for homework. Are there any questions? If you have your test signed and corrected, I will take that right now. I'd like to thank everybody for watching Math with Mrs. Lehman. Eat some pie today in honor of Pie Day. Have a great day.